This is part C of chapter 5, write linear equations in point slope form. This is a new form for us, and we'll take a look at it in a minute. It's very powerful, and powerful things might be a little bit more complicated, so this takes a little while to get used to it first, but it's a very useful form of a linear equation. Now it is restricted to a non-vertical line. Actually, that's been true with slope-intercept form as well. A vertical line has a slope that's undefined, so this works for any line that is non-vertical. Here it is. Y minus y sub 1 equals m times the quantity x minus x sub 1. Now, things that are familiar, things that we've used before, this y will stay y, m is the slope, that x will stay x. The reason we have the subscripts here is because if we used the same thing here, y minus y, that would actually be 0. Even though we didn't mean that, that's what it would be. So, the point x sub 1, y sub 1 is any point on the line. So we're not restricted to y-intercepts here. If we have a slope and any point on the line, we can use this format to write the equation. So here we're given the point 3, 2, which has a slope of 2. So we'll just set up our information here. Remember that this means, and actually I'm going to subscript those, x1, y1, that's supposed to be a comma. I'll try that again. A lot of times we just read that x1 or x sub 1, sub is short for subscript, y sub 1 can be any point on the line, and we're told that 3, 2 is on the line, and m equals 2. Now this time I really do want you to write down the template, because writing this down helps you get used to it and helps you memorize it. So here's our new format. So like we did with slope-intercept form, y stays y. Y sub 1 is the y coordinate, which is 2, equals m, which is also 2, times the quantity x minus x sub 1, which is 3. That's done. We will work towards a time when slope-intercept form is kind of our default format, but since we're doing point slope form, we're done there. Now we're back to a little bit of graphing, and now we've kind of got the reverse situation. We're given the equation. I'm going to ask you to write down the template here. And now, instead of putting information into the template, we're getting information out of the template. So I'm just going to copy that equation down, and it fits very nicely, right? Meaning y1 is whatever is being subtracted from y, and that's 2. M is the slope. I'll start there. x1 is whatever is being subtracted from x. That's also 2. So now we're kind of doing this in reverse. So we'll write a few directions here. You won't need to write these when you do these, but just so you remember where this comes from. We'll plot 2, 2. So again, our starting point is not a y-intercept because we weren't given a y-intercept. We'll go back to rise over run. Now since we're graphing, remember, we like slope as a fraction. If this were an integer, we'd put that over 1. So a rise over run of 1 over 2, go up 1, right 2, and connect all the way through the grid. Label with the equation. 3. We have a point and the slope. So x sub 1. Now some versions of the notes packet might have some extra words in there. If those are in your packet, just cross them out. But it should read has a slope of 4. So our point is negative 3, 5. We'll use m for our slope again, equals 4. This is a format, this template, point slope form, is something you will eventually need to memorize. I know that on your formula sheet for 8th grade, it's there. After that, though, it's something that you are expected to have memorized. And writing it down as you do these problems, I think, can really help with that. So y stays y. y1 is the y coordinate of the point. M is our slope. Minus x1, which is negative 3. Now we will do a little cleanup on that, and we would do a little cleanup here if our y coordinate had been negative. We can express the same thing in fewer symbols. X minus negative 3 is the same as x plus 3. Number 4, back to a little graphing. We'll write down the template. And this time, we have a little bit of a different situation. I'll write the original right underneath that. Our template has subtraction here, and we have addition. Now, just like you can change add to subtract the opposite, even though we usually don't want to, you can change add to subtract the opposite. Meaning, if 3 minus negative 5 can go to 3 plus 5, and it can, that's familiar, change subtract to add the opposite. Add, opposite of negative 5 is 5, then we can go the other direction as well. And this is a case, and you'll run into more of these cases too, this is a case where we're going to do that, because our template has subtraction. We will change y plus 1 to y minus negative 1. Now that fits our template. Equals 2. Now here, we already have subtraction. Don't change that. So, our y sub 1 is negative 1, and our x sub 1 is 1. And I want to try to not underline that opposite sign. So x1 or x sub 1, y sub 1 equals I have to be careful here with the signs and the order. X sub 1 is whatever is being subtracted from x. That's 1. Y sub 1 is whatever is being subtracted from y. That's negative 1. Our slope is 2. We'll make that integer a fraction by putting 2 over 1. So we plot 1, negative 1. Apply the rise over run of 2 over 1. So up to right 1. And if you want to do that more times, that's fine. We'll connect. We'll get a straight edge and connect. adjust and label with the equation. Y plus 1 equals 2 times the quantity x minus 1. Now we're given some information, and like before, in order to write an equation in whatever format is specified, we need the slope. So, now on a grid you'd be welcome to count the slope, that's fine. I want to be sure that we can calculate it for times when you don't have a grid. So I'll do 2 minus negative 3. Remember, we have the y's, that's the change, the vertical change over the horizontal change. And since I went 2 minus negative 3, I now must go 4 minus negative 2. Going the other direction would have been fine. And I'll change both those to subtract. I'll change both subtract to add the opposite. So I'm seeing a slope of 5/6. As long as I do have a grid, I'll count that out and see. A rise of 5. There might be a quicker way to do that. Let's see. If I was 3 below and I went to 2 above, that's a change of 5. And if I was 2 to the left of 0 and I went 4 to the right, that's a change of 6. So 5/6. Now, choose a point. I'll choose 4-2. And what can happen here, we'll use our template for point slope form. What can happen here is you can have different looking equations that are equivalent based on which point you chose. Choosing 4-2, I get y minus 2 equals 5/6 x minus 4. And point slope form is what was asked for, so that's what we have. If we had chosen -2, -3, then we would have y minus, and I'll just peek at this template as I do this, -3, we'll clean that up in a minute, and we'll clean that up in a minute, equals 5/6 times x minus -2, y plus 3 equals 5/6 x plus 2. Now, these two formats are actually equivalent. They don't look the same, but they are equal to each other. And so what we often do, we won't do it now, but we'll start to do that. We often use slope-intercept form as kind of our default form. That's y equals mx plus b. After we've learned how to change these into y equals mx plus b format, even though I'm pretty sure that's something you'd be able to figure out on your own, then we'll see that we come out with the same thing. And sometimes to avoid confusion, meaning maybe you got this and someone else got that, and you're comparing answers and you're not sure if they're right or not. A lot of times we end up with slope-intercept form. But we were asked for point slope form here, so either one of these is just